Hello everyone. Black holes are one of the most mysterious and intriguing phenomena in the universe. They are featured in everything from science fiction movies to scientific research. So, why do black holes captivate so much interest? There are several key points regarding why black holes are so intriguing. Is it because every black hole requires a star to die? Or because objects that enter cannot escape? Perhaps what captivates us is that the known laws of physics no longer apply. Black holes, and especially the phenomenon we call singularity at their centers, are the greatest phenomena known in the universe. The idea of black holes was first proposed in the 18th century by John Michel. Michel suggested that a star with a large enough mass could have a gravitational field so strong that it could trap light. However, the first concrete evidence of black holes came in the mid-20th century. In the 1960s, scientists like Stephen Hawking and Roger Penrose mathematically proved the existence of black holes through their work on general relativity. The first observational evidence came in 1971 when studies showed that the X-ray source Cygnus X1 was a black hole. The formation of black holes is a complex and fascinating process that occurs during the final stages of a massive star's life cycle. This process can be broken down into 5 main stages. Stars are massive spheres of gas that generate energy through the nuclear fusion of hydrogen into helium. During this stage, stars are in a state of equilibrium between the inward force of gravity and the outward pressure from nuclear fusion. This balance is known as hydrostatic equilibrium, which keeps the star stable throughout its main sequence. As a star's hydrogen fuel starts to deplete, the fusion reactions in the core slow down, causing the core to contract. As the core shrinks, the outer layers expand, and the star becomes a red giant. During this phase, the star begins to fuse helium into carbon and oxygen in its core. If the star has a mass about 8 times greater than that of the Sun or more, its core eventually starts producing iron. Since iron fusion does not produce energy, the core undergoes a sudden collapse. This collapse triggers a massive explosion known as a supernova. The supernova ejects the star's outer layers into space, while the core becomes incredibly dense. After the supernova explosion, the remaining core will become either a neutron star or a black hole, depending on its mass. If the core mass exceeds approximately 2 to 3 solar masses, it forms a black hole, which is denser than a neutron star. The core continues to collapse under the force of gravity, leading to the formation of an event horizon. The event horizon is the boundary surrounding the black hole, beyond which nothing, not even light, can escape. As the core continues to collapse, the density and gravitational pull of the black hole reach near infinite values. At this stage, the black hole becomes one of the most dense and mysterious objects in the universe. Black holes exert a tremendous gravitational force on surrounding objects, including planets, stars, and gas clouds. As these objects approach the event horizon, they accelerate and heat up intensely, emitting powerful X-rays. The most defining feature of black holes is that light cannot escape from them. This is because the gravitational pull within the event horizon exceeds the speed of light. Hence, black holes are black because nothing, not even light, can get out. Black holes harbor the greatest mysteries of the universe. Scientists continue their efforts to understand these cosmic giants better. The more we learn about black holes, the more we will understand the workings of the universe.